A new generation of running gear is very important to achieve the ambitious goals set up by Shift2Rail for future European rail vehicles. This includes significantly reduced life cycle costs, improved reliability and energy efficiency, and also reduced vibrations and noise emissions. NextGear therefore develops a variety of innovations for future running gear.
The reduction of the mass of the wheel set is related to the importance of reducing the mass of all the parts coming into contact with the track. This helps to reduce the damage of the rolling stock of the rails and also reduce the noise and the vibration coming from the vehicle. So in Work Package 3, we developed a technology concept of a hybrid metal composite axle. And the weight reduction we achieved for the axle was 60%, and the overall mass reduction for the wheel set was 14%. To develop this hybrid composite metal axle, we had to face a lot of challenges. First of all, we had to design the structure, we had to optimize the fiber layout, but then we had to study the connection with the metal parts and the connection with the bearings, the wheels, the position of the brakes. Then we had to consider feasible ways of inspecting these complex parts and also ways to perform structural hand monitoring of the parts.
There's huge potential from using new materials and new components and new methods of operating these components. And in particular, in Work Package 2, we've been investigating two potential improvements. One is the use of fiber-reinforced plastic to make a lightweight frame within the bogie of the vehicle, and the other one is use of additive manufacturing methods, where we make a novel component which is lighter and more robust and potentially more reliable than the existing components. We are also developing a high safety integrity level controller. This controller is necessary so that we can control the different active components which we have in the suspension. Using active components allows us to improve the performance of the suspension, for example by reducing the damage on the track and reducing the energy consumption of the vehicle.
A challenge in using composite materials in running gear is to prove that they can fulfill all the requirements on lightweight vehicle components. This has been addressed in Work Package 2 through the conceptualization and design of a lightweight carbon fiber frame, which was tested here in the Lightweight Structures Laboratory at the Royal Institute of Technology. The work has demonstrated that carbon fiber composites can be used as part of a novel running gear. We achieved significantly reduced mass and better or similar performance to a conventional running gear.
Metal additive manufacturing can provide several benefits to the railway industry. We're working with metallic powders and automated machines to make parts in a layer-by-layer fashion. So in NextGear, we concentrated our efforts especially in order to understand how we could change the manufacturing of spare parts, especially where required and when required using digital files. So we collaborated with Metro de Madrid and we redesigned their part using railway data, real railway data, and the component was manufactured here in Milan and tested on the track in Madrid. So we achieved a 60% weight reduction of the component. We were able to put the component from 18 parts down to 2. And we were able to manufacture it in less than 2 weeks compared to a few months in the conventional case. So this was a quite nice way of showing the railway industry the benefits of metal additive manufacturing, which we hope will be used more often in the upcoming years.
The use of active elements may lead to a better trim of the car body approaching the curves by reducing the centripetal acceleration and thus reducing the wear of both wheels and tracks. Moreover, the suspension system, both sensors and actuators, can be monitored to check the efficiency and detect anomalies in their behavior. In the project, we set up a hardware-in-the-loop Still4 controller with simulated sensors and actuators running at 1 kHz. A future improvement could be introducing dedicated I/O boards interfacing real sensors and actuators.
The universal cost model is a simulation framework that enables to compare life cycle costs of different running gear types, especially their impact in different railway system stakeholders. The UCM allows to check for pros and cons of novel, innovative running gears at the system level. The UCM does not simulate directly the innovations, but what it does is simulates the impact of those innovations in different cost-generating concepts. What it means is that for the NextGear project, we could not model all the innovations, and what we have done is to explain and break down the process and how a new innovation should be implemented in the UCM in order to be able to calculate their benefits and their pros and their cons. The main challenge is to achieve the right balance between accuracy and user-friendliness, because different stakeholders will have different expertise levels in these simulation techniques and then different expectations of what a good level of accuracy and usability should be.
Additive manufacturing and bogie frames and wheel sets based on carbon fiber materials can significantly reduce the weight of future running gear. The controller and the innovative actuator that we developed in the project show the performance of active suspension in rail vehicles. That will improve the performance and enable new vehicle concepts. The positive impact on the life cycle costs can be verified with the universal cost model that is also developed in the project.